reaction regarding to the alkenes. Types of reactions regarding to alkenes. Alkenes, E-N-E, alkenes. Types of reaction. General types of reactions regarding to alkenes.
Addition.
Addition. Okay, yes, good. Addition. What's the meaning by addition reaction?
Breaking the bond and forming new bond.
Breaking double bond and then forming new bond. Okay, that's what we call as a addition reaction. Okay, next moving to Ammar. Okay, Ammar, give me two types of addition reaction regarding to alkenes.
So firstly, there is addition of halogen to make a halogen alkene, bromine water with any alkene. The rubber bond mix forming dibromo alkane, and then there is addition of there is hydration. Addition with hot phosphoric acid and steam.
Okay.
And liquefied what alkene, it will form alcohol.
Okay, yes, good. So there is two types of addition reaction mentioned by Ammar. The first one, addition with halogen. Okay, to produce halogen-alkanes, and then that reaction will just run under normal condition, no need to supply specific condition. And then the second one, reaction with water, also known as a hydration, and then there is a specific condition you need to memorize in order to produce alcohol. Okay, okay, but today we don't want to talk about addition reaction. We want to talk about another reaction. Okay, Jaida. Now we're moving to Jaida. Jaida, tell me, what is the third type of reactions regarding to alkene? Halogen. Okay, tell me more details about halogen. But I think halogen Amma mentioned already. The next addition reaction. You can see next to Amma for Jaida. Halogen halide. Okay.
It is inside.
Okay, what is it? Okay. Now we're moving to the next one up, okay? So because everyone is here, so let's start our class, okay? With simple, okay? Simple refreshment, okay? Are you ready? Take out your notes. Okay, so you still remember this word? Still remember? Okay, all versus brick, okay? All versus brick. But today we don't want to discuss about RIG brick, but we just want to discuss about OIL. Okay, who still remember what is the meaning from this word?
Oxidation is lost.
Oxidation. O stands for what? O stands for oxidation, right? Okay. I stands for what? Is loss of what? Okay. Loss of electron. Other than electron?
Loss of hydrogen.
Loss of hydrogen, yes. Loss of hydrogen. And then at the same time, when we talk about oxidation, okay, we can say that this oxidation reaction gain of oxygen. So you must remember when we talk about oxidation reaction, okay, we refer to these 3 points. Either the species losing the electrons, okay, losing the hydrogen atoms or gaining the oxygen atom. But when we talk about organic compound, you cannot use these 2 points to explain what happened to the species. Either it's undergo oxidation or reduction, but you need to look at the last point, which is this point. So you must remember when we talk about organic compounds, all the organic compounds will gain, will receive, will accept the oxygen when it's undergo oxidation reaction. Understand? Okay, so this is what we will discuss today in my class. So, is it too dark?
No.
I think maybe we just pull up this one. Is it clear now? Okay, please. Okay, if you look at here today, I will discuss about oxidation of alkenes. So far, before this, we discussed about addition reaction regarding to the alkene. There is 5 types of addition reactions of alkene. Addition with halogen, addition with hydrogen bromide, addition with water, addition with hydrogen, and the last one yesterday we talked about addition of polymerization. Now today, okay, we're going to discuss different types of reactions regarding to the alkenes, which is oxidation reaction. Like I told you before this, okay, in the beginning of the class, when we talk about oxidation reaction, means that we refer to the species that tanning of oxygen atom. Okay? Of course, when we want to undergo oxidation reaction, okay, we need the agent to make sure that species can oxidize to produce different product. So what's the agent to oxidize alkene? So we call as a acidified potassium manganate solution. So this species, this chemical we call as a strong oxidizing agent. Wherever you want to oxidize any species, you need to have the agent. Okay? So what's the agent to oxidize alkenes? This is the names we call as acidified potassium manganate. This is the specific condition you must memorize. Okay, usually question will ask you what is the condition to oxidize alkene. One of the conditions we refer to the oxidizing agent, which is acidified potassium manganate. You must mention acidified, okay? Because this is the condition. If you just use normal potassium manganate, you cannot oxidize alkene. You cannot get a new product. No matter what, if you want to produce new product from alkenes, you need to supply acidified potassium manganate. That's the condition. Okay? So what's the product? What's the product we get after we oxidize alkene? It depends on the condition that we supply into the reaction. Okay? So understand?
Yeah.
Under your syllabus, there is 2 types of condition you need to consider in order to oxidize alkene. The first one, okay here, the first one, you must supply cold dilute acidified. Must be cold and then must be dilute. Cannot use hot and concentrated. Okay? The first condition, you must use cold dilute acidified aqueous solution of potassium manganate at the room temperature. So means that your potassium manganate you must put in the ice bath in order to make sure that potassium manganate cool enough to oxidize the alkenes, and then you can run the experiment. Okay? So if you look at here, this is the example of the reaction. Okay? For example, I have, okay, I will show you the example. Okay, let's use this equation first. For example, I have this alkene, C double bond C, isn't it? Okay, so I just complete the formula using hydrogen atom. Remember, every carbon atom must produce 4 covalent bonds. So this is the ethene. What is this? This O in the bracket represent potassium manganate. When you want to write in the equation to represent the oxidation of alkenes, the formula of the potassium manganate you just represent using O in the bracket like this. Okay? Remember I told you this one represents oxidizing agent. No need to mention the full formula like this KMnO4. No need to mention this full formula when you want to write in the equation for the oxidation reaction. It's enough to represent potassium manganate using O in the bracket. Automatically we understand. O in the bracket here represent the agent, the oxidizing agent. Okay? So the first condition, we supply cold dilute acidified potassium manganate. For example, we have ethene. So when these ethenes undergo oxidation, what happened to the ethene? Ethene stands to produce new product. Okay? Which is we call as a diol compound. Okay? What is the diol compound? Look at this one. From the double bond, okay, this ethene will undergo oxidation reaction, okay, to produce diol compound. Diol compound when there is 2 hydroxyl groups, okay, bonded to the product like this. So we have H here. Okay, here this is the original H. First carbon, second carbon. I have 2 hydrogen. Same goes in the product. At the first carbon I have 2 hydrogen. At the second carbon I have 2 hydrogen as well. But now we introduce 2 hydroxyl group. Actually, this 2 hydroxyl group is compound or the reactants gaining the oxygen during the process. If you look at here, is it ethene gains the oxygen during the process? Is it ethene accept the oxygen from the potassium manganate during the reaction? Yes, isn't it? From 0 oxygen is produced 2 oxygen atom. Okay, so means that we know this ethene is undergo oxidation reaction. So what is the name of this product? We call as a diol compound. Diol. Di means that there is 2 what? Why OL? OL represent what kind of the homology series? Alcohol, isn't it? Alcohol. What is the functional groups of alcohol? OH. So because there is 2 OH groups in this compound, that's why the names we call as a diol. Diol or diol. Understand? That's the first condition you must remember. When we have cold dilute acidified potassium manganate, automatically alkenes will turn to diol compound. This is the product. So far, understand? Any question? No question. Okay, I'll give you 1 minute, okay, to copy the notes faster. Oh, but one more thing before that. So you will see the observation. When you run this experiment, you will see the purple color of potassium manganate will turn to colorless. Okay? You must remember acidified potassium manganate, the original color is purple. So when the species or when the reactant is undergo oxidation, what happens to the potassium manganate? It turns to colorless. When it turns to colorless, automatically we know that species is complete oxidized to produce new product. That's the keyword slide. That's the point. How do you know either reaction is still going on or is already complete? Okay. So when the potassium manganate, the purple color of potassium manganate, totally 100% changing into colorless solution, automatically we can say that all the species has been oxidized during the experiment. Yeah, understand? The second oxygen, this one also is considered as a hydroxyl group. We have one hydroxyl group, second hydroxyl group. Hydroxyl we refer to the functional groups of alcohol, which is OH. Sorry? O and also O from potassium manganate. But we just use 2 from potassium manganate because of the condition. We did not use all 4 oxygen, okay, from the potassium manganate. There is a mechanism extra cover for your syllabus. So that's why for the time being, you just remember when you have alkenes, you supply this condition, you're going to have diol compound. Okay? Ethene or propene or any alkenes, okay, when you supply cold, dilute, acidified potassium manganate, you're going to have diol compound. You're going to get diol compound. Okay, when you run the experiment. No byproduct. Okay, there's only main product, which is diol compound. Done? Okay, now we're moving to the second condition. Okay, second condition is quite complicated because we have 3 different products. If you look at here now, second condition, I supply hot. Hot means that I need to heat the sample. I heat the sample under certain temperature and then I need to use concentrated acidified potassium manganate. I cannot use dilute. I need to use concentrated and also hot condition. And then when I supply this condition, what happens? What is the product? Okay, of course, you must understand the point first before we look at the product. What is the product we get when we supply hot concentrated potassium manganate? Okay? When we run this experiment, this experiment which is referred to the vigorous or harsher condition. Very, very vigorous condition because you heat the reactant, you heat the sample until certain temperature. So when you heat the sample, automatically first step C double C will be break first. Okay? And then after that, there is a further step which is deep by potassium manganate. The OH will be formed and then further oxidized to produce either ketones, aldehyde or carboxylic acid. So there is 3 different products. Okay, there is 3 different products you will get when you supply hot concentrated acidified potassium manganate. It could be ketones, it could be aldehyde, it could be carboxylic acid. Okay? And one more thing is, okay, you must remember the actual product depends So this is the list of the product. Okay, we will get when we oxidize alkene using this condition, hot concentrated acidified potassium manganate. So this is the summarization. You must remember. If there is two hydrogen atoms bonded to the carbon atoms in C double bond C, okay, try to understand first. If there is two hydrogen atoms bonded to C atoms in C double bond C, automatically the product is CO2. If one hydrogen atom and you have another one alkyl groups bonded to the C atoms in the C double bond C, automatically the major product is carboxylic acid. And then the third one, if there is two alkyl groups, okay, bonded to the carbon atoms in the C double bond C, so the major product will be ketone. Okay, let's say, look at the example. Copy first this one. Okay, 1, 2, 3, only these 3 points. If there is two hydrogen atoms bonded to the carbon atom in the C double bond C, automatically the product will be CO2. One hydrogen atom and one alkyl group, it could be carboxylic acid.
So those 3 points only apply when the potassium manganate is hot.
Hot and concentrated.
So
It's
when
not valid for the cold and
when it's
dilute.
cold, we get diol.
Yes, only diol compound. Okay, if you supply cold dilute potassium manganate, we have only one product which is diol compound. But if you supply hot concentrated acidified potassium manganate, it will be 3 different products. It could be ketone, it could be carboxylic acid, it could be CO2. It depends. It depends on the what types of the carbon. Sorry, what types of the atom bonded to the carbon atom in C double bond C. C double bond C, and then I have H, R. H, and then R prime. So remember, these R stand for what? Side chain, isn't it? When we talk about side chain, it could be what? It could be anything. Is it anything? What's the meaning by R? R can stand for what? Yes. Okay. Alkyl groups. So when we mention about alkyl, it can be what? Methyl, ethyl, propane, and so on. Okay. Let's say this R belongs to methyl groups CH3, and then the other side of the carbon in the C double bond C, I represent using CH2CH3. Okay, remember now we talk about hot concentrated acidified potassium manganate. The product, the product will be ketone, carboxylic acid, or carbon dioxide. So what you need to do is you just look at the atom. What is the atom? What is the species bonded to the C double bond C? So you just focus on the C double bond C. Now this is my C double bond C. This is the first carbon and second carbon. And then after that you need to identify what is the atoms bonded to the carbon involved in the C double bond C. So for the first carbon I have R groups. And then the second one I have hydrogen atom, isn't it? So automatically what's the product? When we have one R groups and then one hydrogen, so the product will be what? Carboxylic acid, isn't it? Remember in the previous slide, list of product. It could be CO2, it could be carboxylic acid, it could be ketones. Okay? CO2 when there is 2 hydrogen atoms bonded to the carbon in the C double bond C. Carboxylic acid when there is 1 hydrogen atom and 1 groups bonded to the C double bond C. And then we can get ketones if there is 2 groups bonded to the carbon atoms involved in the C double bond C. So if you apply this concept to this example, so the first part from this ethene, okay, we're going to have what? We're going to have 1 R groups, 1 hydrogen. So we're going to have carboxylic acid. Okay? And then what happened to the second carbon? We have 1 hydrogen and then we have 1 R groups. So means that the both sides that tends to produce both carboxylic acid. Okay, how to find? How to get the product? It's easy, like I told you, because we supply harsher condition, very vigorous condition. So the first step, the C double bond C will be break. So you break this double bond and then automatically you just look at to the both sides. So first we look at the first carbon. At the first carbon we have C and then CH3, isn't it? CH3 and then double bond. But you must remember, because we want to produce carboxylic acid, what is the functional groups of carboxylic acid? What is the functional groups of carboxylic acid? COOH. Now just focus on the carbon, first carbon, and then just introduce functional groups of carboxylic acid. C double bond OOH. First carbon. Okay, C double bond OOH. And then next carbon we have what? CH3, isn't it? So we just continue the formula CH3. C double bond OOH CH3. So this is the first product we get from this reaction, from this reactant. Okay? Understand? And then what happened to the second part? The second part we have same pattern, which is we have 1 hydrogen and 1 alkyl groups. So means that carbon number 2, second carbon also produce carboxylic acid. Again, just focus on the C2 here. I have C2 here, and then look at here. C2 here, there is no more hydrogen. There is no more hydrogen. Why there is no more hydrogen? What happened to this hydrogen? Why there is no more hydrogen in the product? Remember definition of oxygen? What is meant by oxidation? Oxidation of species?
You lose hydrogen.
Yes, losing of hydrogen, isn't it? This is happening in this reactant. When the reactant undergo oxidation, they tends to gain the oxygen, but at the same time they tends to lose the hydrogen atom. That's why there is no more hydrogen in the product, because this hydrogen, okay, losing during the process. So plus C2, look at C2. C2, now we don't have hydrogen anymore because it's already loose during the process. So what happened to the carbon number 2? You just introduce functional groups of carboxylic acid. C double bond O, OH, and then the rest of the formula you just copy from the original reactant. Now we have what? After C2 you have dash, and then CH2, CH3. CH2, CH3. So this is the product we get after we oxidize this reactant using hot concentrated acidified potassium argon. So understand?
Yes.
Any question you want to ask me? Okay, I'll repeat it. First, what you need to do is to just identify what is the species bonded to the carbon involved in the C double bond C. If there is 1 hydrogen and 1 alkyl groups bonded to the carbon in the C double bond C, automatically we know that tends to produce carboxylic acid. Same goes to the second side. You just look at, you just identify what is the atoms bonded to the C double bond C. And then you can deduce the product. So how to deduce the product is easy. You just focus on the C double bond C. You break this double bond C and then you introduce new functional groups. Depends, okay? Depends on the what kind of the atoms bonded to the C in C double bond C. Okay? So what's the name of this product? After you understand how to identify, how to draw the formula for the product, you need to know how to name the product. Remember the homology series? The previous chapter, we have C double bond OOH. This is the functional groups. This is the functional groups of this species, C double bond OOH. Automatically, we know this species is under what kind of the family, what kind of the homologous series? Carboxylic acid. So how to name it carboxylic acid? You're supposed to know because you learn already in secondary as well. How to name it? How to name this compound? Ended with what? Oil, right? Oil, remember? Okay, I recall, okay, that content, okay, during the previous class. So you must end it with oil. And then what you need to do is you just look at to the parent's name. How many carbon in the parent's name? 2. So means that 2 becomes ethanoic acid. ETH. Ethanoic acid. Ethane, remember? The order ethane. When there is 2 carbon atom, ethane, and then why we ended with oil? Because it belongs to homologous series, which is carboxylic acid. Understand? If I mention like this, ethane, F-A-N-E, why this name ended with A-N-E? Because of what?
It belongs to alkane.
Yes, because this species belongs to the homologous series, which is alkane. There's only C single bond C. What happened if the name I ended with ethene, E-N-E? What kind of the homologous series belongs to this species? Alkene. Okay? And then if I have ethanol on. Ketone, yes, good. So that's why I told you actually from the names you can identify the species belongs to what kind of the homologous series. Either it belongs to carboxylic acid, either it belongs to alkane, or ketone. Okay, so we go back to this question. Okay, ethanoic acid. Everyone understand how to name this compound? Okay, moving to the next one. Okay, look at this one. You see, we have same carboxylic acid. No, we have different carboxylic acid, isn't it? How do you know we have different carboxylic acid? Because we have how many carbon in the main chain, in the parent chain? How many carbon in the main chain? 3, isn't it? See? 1, 2, 3. 1, 2, 3. So when there is 3 carbon in the parent chain, so the names we call as a prop. Okay? That's the name. Prop what? Propanoic acid. And then with oil, propanoic acid. That's the way to name the compound. Understand? Okay, now we're moving to the second example. Okay, I hope you understand, okay, this pattern. What happens if I have something like this? If you don't have enough time to copy my notes, okay, you can take a picture later on, you complete your notes, okay? What happens if I have something like this? CR, double bond CH. So again, look at to the list of the product. And then you need to consider both carbon involved in the C double bond C. Just focus on the C double bond C. Now I have 1 and 2. Carbon number 1, carbon number 2. At carbon number 1, I have 2 R groups. So 2 R groups, it could be ketones. Automatically you have the idea. When there is 2 R groups bonded to the carbon involved in the C double bond C, so I can predict the product will be ketone. Understand so far?
Yeah.
So this side, okay, we have the idea, we're gonna get ketone. What happened to the other side? Okay, the other side we have 2 hydrogen atom bonded to the second carbon. So automatically I have the idea, oh, I will get CO2 because there is 2 hydrogen atom bonded to the C double bond C. CO2. And then you just draw the product. Let's say I have this example because I want you to name it the compound later on. I have CH2CH3. This one CH3. This one I have hydrogen. Remember? Okay, this is the R groups. Because R, it can be metal, ethyl, propyl, and so on. Okay. So when you have 2 alkyl groups bonded to the carbon involved in the C double bond C, automatically you got ketone. So you just split the part, okay, split the C double bond C, look at to the first carbon atom. At the first carbon atom we have C, isn't it? C. Just copy the formula first. C1. And then next we have CH3, isn't it? We have CH3. Okay, now we have This carbon is not stable, isn't it? Because there is only 2 covalent bonds. So that's why you need to introduce the functional groups of ketone, which is C double bond O. C double bond O. Remember functional groups of ketone? C double bond O, ketone. Ketones, okay, we have C double bond O in the middle. Actually, you can rotate the formula, okay? Turns like this. C double bond O, okay, just rotate, and then I have CH2, CH3, and CH3. It's the same things actually. I just rotate the formula to have different view so that you understand. This is the functional groups of ketone. You must have C double bond O. If you have alcohol, the functional groups of alcohol is OH, always ended at the compound like this OH. But now we talk about ketone. So when we talk about ketone, you must make sure the C double bond O is always in the middle of the carbon chain. Always in the middle of the carbon chain, like this. This is your parent chain, this is your long chain, your main chain. So your C double bond O must be in the middle. Okay, that's the way you draw the functional groups for ketones. Okay, it's up to you. You can draw your product, okay, your formula of the product using this formula or the second formula. Both you can accept as long as the C double bond O must be in the middle. And then what happened to the second carbon? Plus CO2. Yes, like this. So this is the product we get after we oxidize this compound. Any questions so far? Which part you don't understand? Let me repeat. No question? Okay, tell me what's the name of this product? This one, the first product, the main product. This one, of course, I know. This is the carbon dioxide. This one, what's the name of this product? Okay, first what you need to do, when you want to name the compound, what you need to do first?
Count the carbon.
Count the carbon in the main chain, isn't it? So this is our main chain. This one. This is our main chain. And then after that, after you count number of carbon atom in the main chain, what you need to do? We're numbering the carbon atom in the main chain, right? Okay, first if you look at here, we have how many carbon in the main chain? 1, 2, 3, 4. So 4 stands for what?
Bute.
Okay, bute. B-U-C. Bute. Okay? And then after that, because we have the functional groups in the middle here, so you need to mention the location, the position of C double bond O. So how to number the carbon atom? You need to start from right to left or from left to right? Who said that you need to number the carbon atom from right to left? Let's have your hand. Confident with your answer, how to number the carbon atom? We need to number the carbon atom from right to left or left to right? Right to left. Let's have your hand. I want to see understanding. 1, 2. Okay, except for Anwar. Anwar, you mentioned? Okay. So supposed to be we need to number the carbon atom from right to left, isn't it? So means that this carbon becomes as a carbon number 1. 1, 2, 3, 4. Why you need to number the carbon atom from right to left? You cannot number the carbon atom from left to right like this. 1, 2, 3, 4. Why? Give me the reason why we need to number the carbon atom from right to left. Okay, first, yes, good. Okay, correct. Because remember, when we want to number the carbon atom, we must make sure the functional groups always produce small number. If you number the carbon atom start from left to right, what happens to the functional groups? Produce big number at carbon number 3. That one is wrong. It's not valid. Okay? So that's why you need to number the carbon atom from right to left. Okay? Okay, after you know how to number the carbon atom, either you start from right to left or left to right. So you can mention the position of the functional groups. So if you look at here, the functional group C double bond O located at carbon number 2, right? So you put number 2. Bute 2 what? On, okay? O and E. Bute 2 on. That's the way you name the compound. Bute 2 on. The first structure also, yes. Okay, look at if you draw this formula, you still got the same compound because of what? chain. So if you look at here, this is our main chain. Okay, 1, 2, 1, 2, 1, 2, 3, 4. This is my parent chain. Okay, for this compound. So still same, we have C double bond O at carbon number 2. We have 4 carbon in the parent chain. So that's why the names also build 2 on. Understand? So that's why I told you both of the compounds actually is the same compound. But the way you write the formula is different.
It's butane 2, right?
Build 2?
It's butane 2 with the EN.
Oh, okay. Oh, but thank you. Butan 2 on. Like this, butan. Forgot to put in. Butan 2 on. Okay, butan 2 on. Butan 2 on. Okay.
No. Like instead of A, E.
Butane, let me check for a second.
This
It's a butane.
this from here is small.
Yeah, it's E.
Okay, butan 2 on. Okay, like this class. Butan 2 on. This one. That one also can, Amar. But for our syllabus, we just follow the textbook, okay? Usually we just use this one, butan 2 on. Okay? Always follow the syllabus, okay? Okay, any question regarding to the second example?
Yeah, teacher. Why do we mention the position of the double bond for this one and not for the one before, for the carboxylic acid?
Carboxylic acid, also you need to mention the position if there is more than 3 carbon atoms in the main chain. If there's only 2 carbon atoms in the main chain, for example, ethanoic acid, like this, C double bond O, OH. Is it necessary for you to label the position of C double bond O in this compound? No, you can mention. You just mention ethane, ethanoic acid. Ethanoic acid. But what happens if I have more than 3 carbon in the main chain? For example, like this. This C double bond O, OH. Okay, if you have something like this, 1, 2, 3, 4. For the carboxylic acid, okay, usually you don't need to mention the location of C double bond O because of what? Because C double bond O, OH always located at the first carbon atom. Always located at the first carbon atom. You cannot put C double bond O, OH in the middle of the carbon atom, isn't it? Always put C double bond O at the first carbon atom. So that's why for the carboxylic acid, it's not necessary for you to label, to mention the location of C double bond O. But if you talk about ketone, yes, you need to mention the location of C double bond.
Because the double bond in the ketone can't be at the end.
Cannot be at the end.
So it's just going to be butanone, I think, because it's either going to be on that one or the one next to it. So it's still.
1, 2, 3, 4, butan to 1.
No, it can't be on the either end.
Yes.
Because then it will be.
In the end means that. What do you mean? Is it like this?
If it's at the end, it's going to be an aldehyde.
Yes. That's why I don't want to introduce this because that one is another functional group, aldehyde.
So if it's in, it can be either in the one in the middle too, right?
Yes, either
so
2
it's
or
going to be
3.
butane 2 on. So do you have to include the number in this case?
For this one, I prefer you put number lah. Okay, even though it can be here or it can be here, both same position, but to be safe, you just put the number. If there is more than 3 carbon atom in the main chain, okay, just remember if there is if there is more than 3 carbon atom in the main chain, you need to numbering, you need to label the position of the functional groups, either ketone or alkenes or alcohol, except for carboxylic acid. Carboxylic acid, no need to mention the location of C double bond O, OH because of what? Because it's always located at the first carbon, like this. Ethanoic acid, hexanoic acid, C double bond O, OH always at the first carbon atom. What happens if I have something like this? C. This one. First, what is this? What is the functional groups of this compound? Functional groups, tell me the functional group first. Ketone, isn't it? Ketone, right? Because we have C double bond O in the middle of the chain. C double bond O. And then what you need to do is you need to number the carbon atom. Okay? So 1, 2, 3. Okay, for this case, okay, it's valid. I didn't want to number it from left to right or right to left because both sides produce same number of functional groups. 1, 2, 3. So how to name it? 1, 2, 3, 4, 5. There is 5 carbon in the main chain. So it belongs to what?
Pen.
Pen. Okay, pen. Pentane, 3 on. Okay, pentane 3.
When it comes to hexane,
Hexane, okay, hex 3 on. Okay,
can
hex.
zero be considered as a third and fourth carbon?
Hex. So if you have 6 carbon, like this. So 1, 2, 3, 4, 5, 6, and then the double bond located in the middle like this. You see like this one here? Okay. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So which one you need to number in the carbon atom? From left to right or from right to left? Left? Left to right. Okay.
Well, teacher, I was asking if we can position the CO on the
Which carbon?
the fourth one.
The fourth one, okay? This one still produce ketone. It's not necessary you must put in the middle of the carbon chain. It can be here plus, it can be here, it can be here, or it can be here. As long as not at the first carbon and also at the last carbon atom. Because that one will be produce different functional group, which is aldehyde. If C double bond O located at second carbon, so the names become hexane 2 on. If C double bond O located at the third carbon atom, so the names becomes hexane 3 on. Okay? Okay. So go back to this question. Any question you want to ask me regarding to the product, okay, produced when you supply hot concentrated potassium manganate to the alkene? Any question, Okay. Then, this one. So, after you know what's the product, you need to know how to detect presence of alkenes in the unknown compound. Let's say I have 2 unknown samples like this. I have 2 unknown samples like this, and then I don't know which boiling tube, which test tube containing C double bond C. So what I need to do? So I need to run certain tests. Okay, we call it a barrier test. This name we call it a barrier test. Okay. So how to run this test? You just run the first reaction. Still remember the first reaction when we oxidize alkene? What is the first reaction when we oxidize alkene? What is the first condition we need to supply to the alkene?
The
first one.
Potassium manganate.
Potassium manganate. Yes, I know the first condition. Cold dilute. So you must run that test. You must run that experiment in order to know which test is containing C double bond C. So that's why if you look at here, I just mentioned here, we must react alkenes with cold dilute alkaline potassium manganate. So when you run this experiment, you will see 2 different observations. The first observation, you will see purple color of potassium manganate will turn to colorless, decolorized. From purple becomes colorless. No more purple color inside the test tube. So automatically you can make the conclusion, oh, this test tube has a C double bond C, containing C double bond C, containing alkene. And the second observation, sometimes you will see they tend to produce brown precipitate. Okay? Maybe later on, about 1-2 minutes later on, you will see there is a brown precipitate produced inside the test tube. So when there is brown precipitate appear in the test tube, automatically we can say that it's due to formation of manganese oxide. Okay, so that's why we can say that there is alkenes in the test tube, in the unknown compound. So this is how the equation looks like. When we have cold dilute acidified potassium manganate, we tend to produce diol compound. At the same time, we have the side product, MnO2. But this side product, I need to mention when the question asks you to write in the equation. I just want to show you how do we get brown precipitate. When you run this test, you're going to see brown precipitate due to what? Due to MnO2. This oxidizing agent is undergo reductions. Okay, it's reduced to produce MnO2. The slide is not quite clear, right? No? So this one from here, this is the different test tube. We have purple color remain in the test tube, and then we have brown precipitates appear in the test tube. So what's the conclusion you can make? Which test tube containing C double bond C?
Brown.
The one that produces brown precipitate lah. Okay? So the one that produces brown precipitate, you can make the conclusion inside the test tube there is C double bond C. Okay, understand? Okay, let's try again to run this test.
On previous slide, you say alkaline, right? Alkaline
alkene. Okay. Any question?
You still get the same result though.
Yes,
right?
we still get same result. We still get diol compound if you use alkaline potassium manganate. Okay, now I want you to see in the groups. Okay, divide into 1, 2, 3, 4, 4 groups. Is it okay? I give you only 5 minutes. Okay, try. Okay. 1, 2, 3 of you. Okay, in one group. 1, 2. Okay. Okay, move. I need to move. I think just turn it back. Okay. 1, 2, 3. 3 of you. Okay. 3 of you. And then 3 of you. Okay, what you need to do is, okay, in the test tube bag there is 4 different test tubes. And then here we provide you with the potassium manganate. This is the potassium manganate, acidified potassium manganate. Look at the original color. It has purple color, isn't it? Okay, this is the original color for potassium manganate. Then I want you to explain to me later on, okay, which test tube containing C double bond C. Okay, you can do it now. Okay. Make sure you just put the potassium manganate drop by drop like this. Look at how it is.
How many drops?
Only 2 drops, slowly added into the solution. Okay, let's say I have this test tube. Okay, I just put 2 drops of potassium manganate. 1, see. Very nice and beautiful color. Okay, what happened? What's the conclusion for this test tube?
No, C
No,
double
C double bond C.
bond.
How do you know there is no C double bond C? You cannot see from your eyes, I think. How do you know? No color change because the purple color just remain in the test tube, right? So that's why we can say that, oh, inside this test tube there's no C double bond C. It could be what? It could be ketone, it could be alcohol, it could be carboxylic acid, but not alkene. Understand? Okay, now I want you to run this test. It's a simple test, and then tell me the conclusion. Okay, everyone must try. Okay, how to see the must try everyone. Only 2 drops slowly added the potassium manganate to the test tube. Wow, so nice. This one. Beautiful. How is it?
Is this one? My one is
Ada teacher.
Oh shit. Yes, it is.
It's white. Yeah.
What precipitate? Is it considered C double bond C? Supposed to be what? There is only 2 observations. Colorless or the second one? Brown precipitate. So you need to find these 2 observations in your test in order to identify which test is containing C double bond C. Can you put more potassium manganate? I want to see the Okay, I want to invite chat groups to explain, okay, your result. Faster, I give you only 1 minute. Tell me, explain.
Like this one is double bond, carbon double
Are you sure double bond? Are you sure there is double bond inside that test tube?
Right, because it's brown.
Okay, good. Okay, next.
So for this one, it's not because it's colorless.
It's colorless, are you sure?
Oh, it's not brown.
Because the purple color remain in the test tube.
So for this one, same, it's not double bond C because it's not brown color.
And also the purple color remain in the test tube, right?
Yes,
Okay.
and same for this one.
Okay, good. Thank you so much. Okay, now Ahmed groups. Choose one of your groups. Okay.
What's that?
Samir, explain to me what happened to your test tube. Samir, explain to me what happened to the test tube. Sure. Okay. Ahmed, what happened to the rest of the test tube? Just purple. So means that there is no C double bond C in the rest of the test tube. Okay, except for that one. Okay, Ian, explain to me what happened to your test tube.
There's a tube number 1.
How do you know there is alkene?
Because
Okay.
And the others, the
Okay. The rest of the test will just remain the normal color, right? Okay, now the last one. Hajar, tell me what happened to your sample, the test tube. Can you check out the test tube so that you can show to your friends? What's the conclusion from that test tube? How do you know it contains double bond? Okay, brown color form, and then the second one because the purple color, right? Yes, purple color disappear. Okay, but if you look at here, the rest of the test tube still remain as a purple color, right? There's no brown precipitate, but the purple color just remain in the test tube. So means that we can conclude these three test tube. There is no C double bond O. Sorry, C double bond C. It could be ketone, it could be alcohol, it could be carboxylic acid. Okay, that's the way you test presence of C double bond C in the atom compound. Okay, any question regarding to this test? No. Okay, now I want to check out this question. Okay, Pastor, we just left about 5 minutes. Okay, check out this question, the one that I gave to you yesterday. Have you read this paper? Yesterday I gave it to you this paper. Okay, but before we proceed with the question, okay, I want to call Samrin, can you make a conclusion? What do you learn today? What's your understanding from my class today? What do you learn today? Oxidation. Okay. Khairullah, what do you understand from my class today? What do you learn today in my class? Give me the conclusion.
There's more reactions when you add hot acidic, hot concentrated acidic compared to cold acidic.
What's the product?
For the hot concentrated one is better response it produces carbon dioxide, and there's one alcohol is
Ketone, right? Ketone. Okay. So make sure you remember there is two types. Listen class, there is two types of oxidation. The first one called dilute. You tend to get what? Diol compound. The second condition? Hot. Concentrated. So we got how many types of product?
Three.
It will be CO2. Okay, very good. Okay, now moving to the next question. Okay, now moving to the next question. I want you to answer question number. No, number 10.
Which
Okay.
one number 10?
The first number 10. Okay, the first number 10 is one. I want you to answer. Number 10 is easy. Okay, we just take it the challenge question. Okay, which is question number 11. 11D. 11D. 2-methyl butene. 11D. Okay, I'll give you 2 minutes to solve the problem. Okay, only 2 minutes. It's quite easy. Okay, the equation.
What? 11D or 10?
11D. 11D. D-I and D-I-I. Yeah. Have you? 11. 11D. Write the formula for 2-methyl butane. 2-methyl butane class. How to draw the formula? 2-methyl butane. Huh?
Yeah.
How to draw the formula? First, look at the parent's name. But means that it's containing how many carbon? 4. And then this number represents what? What's the information you can get from the number? 2. The position of C double bond C. The position of C double bond C. How do you know that the C double bond C is compound? Yes, because the name is ended with E and E. Automatically we have the idea, oh, this compound belongs to ethane. And then what happened to this? What happened to this part? Huh? What happened to the method?
The method is just like
What happened to the method? It comes as a side chain. Side chain carbon?
2.
Yes, good. So means that you have 4 carbon, 1, 2, 3, 4, and then the double bond located at carbon number 2, like this. And then the methyl groups bonded at carbon number 2 as well. CH3. And then what happened to the rest of the carbon? You just complete with the hydrogen atom. Okay. Okay, this one, is it we need to put hydrogen at the second carbon? Is it we need to put hydrogen at the second carbon?
No, it already has 4 bonds.
Yeah, good. Because it already has 4 covalent bonds, so no need to put hydrogen at the
But
second
wait,
carbon.
teacher, what if you move the double bond to the
Can
next
also,
one?
can also. Then, because I start numbering from here, 1, 2. Sorry, here. Okay? Like this. So 1, 2, 3, 4. Okay, understand?
Yeah.
So this one, how many hydrogen you need to complete? 1 or 2? Okay, only 1 now. 1, 2, 3, 4, and then the rest 3. Okay, proceed with the next question. Okay, heated with concentrated acidified potassium manganate.
How do I draw that? Do I just draw the O in the bracket?
What do you mean?
Potassium manganate.
Oh, no need, because the question just asks you to draw the product. No need to write the equation. Just draw the product.
Yeah.
After you oxidize this species, so what's the product we get from this species? This is under oxidation reaction. Okay, faster 1 minute, gone. You left 1 more minute. For DI is easy. 11 DI. I will call your name, okay, and then you need to show your answer. What's the answer? What do we get? Okay, after we oxidize 2-methyl butane. Yeah. Recall from the notes. Okay, take care of your answer. Go to write down first. I will compare your answer with your friend's answer. Answer. So this one from Kyle to Google. Okay. Sit down. Come in. Okay, Ahmad, show me your answer.
For what?
Okay, try it out. Yes. Sit down. Low.
Do I do structure for me? Like, why should the function do separately, or can I just write C5H?
No, just make it easy formula.
C5H can
No use structure formula. Just use this formula. So it's easy for your friends to understand. No, just write the formula and then you product. Okay?
Me
Okay,
first.
I wrote. Okay. So CH3, C double bond OH, yes, correct. What happened to the second part? We have C double bond O in the middle, C double bond O in the middle, CH3, CH3. Good. Okay, means that correct.
Oh,
Okay.
teacher, he copied me.
Okay, look at this one. How much?
Teacher, I thought you were asking me to solve part 2 because you put 2 beside me.
Part 2?
Yeah, the one where they said write the balance chemical equation.
Oh, it's okay, I just look at the equation. So this one also, look at this one. What is this? C and then double bond O, CH3, isn't it? Then we have CH3. If you display the formula, so it becomes like this. So means that correct. This one also correct. There is 2 carbon, ethane and C. And then Ahmad, okay, C double bond O, OH, and then CH3. This one. Okay, what is this? What is the name of this compound?
Zeroic acid.
Ethanoic. I see. Okay, good, correct. And then the second part is belongs to 1, 2, 3. 1, 2, 3. The name is
Prop 2.
propanol, not propanol. Okay. This one I need to label the location of C double bond C because of what? Because there's only 3 carbon in the main chain. But when it comes 4 or 5, when there is more than 3 carbon atom in the main chain, so then you need to mention the location of C double bond.
Okay.
Like the previous example. Okay, in my class just now. Okay,
Teacher,
I
give me
think.
A star.
Huh?
Give me A star.
Okay, I think that's all for today.
No.
Okay, Alhamdulillah. So make sure you revise, go back, revise, and then complete the rest of the question. And then you need to submit this paper. I will consider as your coursework mark.
By the way,
Okay?
Monday.